In this video, we're going to create a very simple web application showing how to integrate FastAPI with Alpine.js. If you want to follow along with this video, there's a GitHub repository with some starter code here that you can clone and you can follow along with that. We're going to build some models with FastAPI and SQLModel, and we're going to learn how to filter a table of results from the database using Alpine.js. Now, I have the starter project open in VS Code here. We have a very simple structure at the moment. We have a database.py file. This contains the code to set up a database in our project with this create tables function. And we also have a get session function. This is a dependency that we're going to use in our FastAPI endpoints. If you want to know more about how to set up a database with FastAPI and SQLModel, check out the video that's appearing on the screen now. Other than that, we have also a templates directory that contains a single HTML template, employees.html. That contains some boilerplate code, but importantly, it loads up Tailwind, Alpine and html into our project. As well as that, we have a populate.py file. We're going to use that later on when we create our models to populate the database with test data for this application. And we have a main.py file here as well that contains a simple FastAPI application. Now, to start along with this project in a virtual environment, you should install the requirements. There's 4 requirements here. We have FastAPI, Pydantic, SQLModel, and 𝗬𝗍. So install those into your project and we can get started by building some models for our employee data. So let's create a file in this project. We'll call it models.py. This is going to be for storing the model data for our database. And I'm going to bring some imports into this file. First of all, from the typing module, we'll import optional and list. And from SQLModel, which is a library that's used to interact with the database, we're importing field, SQLModel and relationship. Now we're going to build 2 models here. Firstly, we're going to build an employee model, and these will inherit from the SQLModel class that we've imported. And for now, we'll just pass on that. And the second class we're going to create is a department class, which will also inherit from SQLModel. Now I'm going to fill in the basic fields for these models here. Firstly, for employee, we have an ID, which is the primary key for that database table. And to specify a primary key in SQLModel, we instantiate a field instance, and we pass the primary key equals true keyword argument. We also have first name, surname, and job title. These are all strings, so they will map to varchars in the underlying database. For the department, we're going to define some basic fields. Firstly, the ID, which is the primary key again, and secondly, the name of the department, which is a string. So that's our 2 tables, but we want to link them together with a foreign key. So how do we do that with SQLModel? Let's define a field called department ID on the employee model. So the employee will have a field in the database that links it back to a department by the ID of that department. That's called a foreign key in relational databases. And the department ID, we're going to make that an optional integer, and we can set that equal to a field. So again, we're instantiating the field. We can give this a default value. So for this case, we're going to give it a default value of none. So that will map to null in the database. And that might be useful if not all employees have a department. And second of all, we specify a keyword argument called foreign key. And this is a string that references where the foreign key will be looking. So it will be department.id. In other words, this foreign key, this field on the employee model, it's a foreign key to the ID on the department model. So it links the employee to a parent department. So that's the basic definition of a foreign key here in SQLModel, but what I'm going to do now is go to the documentation here, and we're going to learn about relationship attributes here. Now I'll link this page below the video. On the sidebar there's a section called what are these relationship attributes. You should read through that, but basically these relationship attributes on a model, they are not the same as fields, so they don't represent a column directly in the database, and the value of these attributes is not a singular value like, for example, an integer. What the relationship field actually represents is the entire object that is related. So in our case, if we look at our example, if we're going to define these relationship attributes, for example, employee.department, we want that department attribute to refer to the entire department that's related to that employee. This is similar to what Django does in its ORM if you're following the foreign key from one model to another. Now to do this with SQLModel or SQLAlchemy, we need to use these relationship fields. So let's define a relationship attribute now called department. and that's going to be an optional department, so we'll reference the department model here in a string, and that is equal to an instance of this relationship object we've imported at the top from SQLModel. And to that relationship we're going to pass a keyword argument called 𝗏𝗶𝗹𝗍𝗓, and we're going to set that equal to a string, and we're going to set that to employees. So when we have an instance of an employee, we can then reference the .department attribute, and that will give us back the entire department model related to that employee. Now this 𝗏𝗶𝗹𝗍𝗓 should reference a field on the department model, so I'm going to paste a bit of code in here, employees, and that matches what we put here. For a department, if we access all of its employees, what that's going to do is we're going to get back a list of employee instances, and again we specify a relationship with the 𝗏𝗶𝗹𝗍 equals department keyword argument. So just to reiterate, for an employee they are linked to a single parent department by the foreign key we specify here on line 11. That's just a single scalar number that references the ID of the department. What we often want in an application is the entire associated department object. We can do that by specifying a relationship, and we can do the same in reverse as well. If we have a department, we want to get all of its employees, we specify the relationship, and these 𝗏𝗶𝗹𝗍𝗓 arguments should match what's on the other model. So that's our two models. Let's save this file. In our database.py file, make sure they are imported at the top, and what we can do is run python database.py as a script. That will then invoke this create tables function. So let's do that just now. Python database.py. And when we run that, you can see that a database file has been created here, and that will have all of the tables that we've defined based on the models we've defined in the models.py file. And to verify that the tables have been created, we can open the database file here if we have the VS Code SQL Explorer. In this case, you can see the tables have not been created, and that's because I've forgotten an argument here for these classes. When we specify the class, we should also specify table equals true, and we do that also for the other model as well. Once you've done that, you can then rerun the database.py file. If you refresh what's on the SQL Explorer, you should now see we have the two tables. So now that the tables are created, we need to populate them with data. We have in the starter code a populate.py file. This contains some code that will populate it with some dummy data. So let's run python populate.py, and if we refresh again the SQLite Explorer, you should now see when we show the table, we have 3 departments in the database: accounts, sales, and management. And each of these will have a set of employees. So at this stage we're ready. Let's build a web app with Alpine.js. Now FastAPI by default is set up to serve JSON data as an API, but it can also serve HTML templates. We're going to set up our FastAPI application to serve HTML. So let's go to main.py here, and we'll go to the documentation for FastAPI, and we have a section here on using Jinja2 templates. There's some imports at the top that we're going to bring in, so let's copy and paste these into the application at the top. From FastAPI, we're importing, as well as the FastAPI object itself, the request object. We're also importing the HTML response object from the responses module, and we can remove the static files import. We don't need that, but we are importing the Jinja2 templates object. So underneath our app object here, we're going to set up a templates object, and this is going to be equal to an instance of Jinja2 templates, and that takes a keyword argument called directory, which is just where your HTML templates live. In our case, we have on the left hand side here a templates directory, so we'll set it to that. What we now need to do is actually serve this employees.html template that we've created. So let's go to main.py and set up a FastAPI endpoint. We can do that with the app.get decorator, and let's say that's going to the /employees endpoint. And for the FastAPI endpoint, we also need a response class. We're going to set that equal to HTML response, and that's what we imported here on line 4. Once we've done that, we can then write our function, which we'll call employees, and we're going to pass the request itself to that function so that we can access it within. So before we write the function to return the template, there's an important bit of the documentation that I want to highlight here, and it's this section here. Notice that you have to pass the request as part of the key value pairs in the context for Jinja2. So when we return a template response, you can see the context here contains the request itself. That's necessary when you're returning templates with FastAPI. So let's set up a context within our function here, and that's simply a dictionary which maps the key of request to the request itself. And then what we return is an instance of the templates.template response, and that takes a keyword argument of the template itself within our templates directory, and that's employees.html. And secondly, we pass the context to that template. So now that we've written this, let's save the file, and we can start the server with 𝗬𝗏𝗀, which is installed from the requirements.py file. We reference the main file and the app object within that file, and we can specify the reload flag so that we can work with any changes that we make while the server is running. When we try and start that, we're getting this error here that Jinja2 is not installed. So let's stop the server and we can run pip install Jinja2. That should have been in our requirements, so apologies that it wasn't. Make sure that you install Jinja2. Then we can try reloading the server. This time we get that the application startup is completed. And if we go to the page, we now see that the template is being served by FastAPI. So the setup is working. What we now want to do is show a list of employees on this page. And we want to use Alpine.js in order to do that, and also in order to filter down the employees by their department and other fields. So let's go back to our FastAPI application. We want to put the employees in the context in this case. Now we need to get the employees from the database. So what we're going to do is go to database.py, and this function here called getSession, that is a FastAPI dependency. It yields the session object that you can then use to interact with the database and your FastAPI endpoint. So what we're going to do is import this from the database file at the top of main.py, and as well as that, I'm going to import from SQLModel the select function and the session class. Finally, one other import from FastAPI, because we're going to use dependencies, we're going to import the depends class from FastAPI. So in order to use that dependency, what we do is we pass another argument to our FastAPI function, and that's going to be an argument we'll call session, and that's an instance of the SQLModel session object. And we can set that equal to a dependency and pass the get session that we imported here. So just to reiterate what this is doing, we are passing a session to our FastAPI function. We type in that as a session object from SQLModel, and we pass that in using depends from FastAPI. So that's now available in our function. What we can do is then grab all employees from the database, and we can call the session.exec function, and we're going to execute a query that's going to return all employees from the database. So we're going to use the select function from SQLModel, and we pass the employee model to that. That gets all of those employees from the database. We can then add these employees to our context. We'll give it a key name of employees, and we set that equal to those employees that we've fetched from the database on line 16. What we're now going to do is show those employees in a table within our template. So let's go to the employee template, and below the h1 tag, we're going to paste some code here for a table. So this table has some header columns: first name, surname, department, and job title. And it uses some Tailwind CSS classes to make this look a little bit better on the front end. We have an empty table body, so what we're going to do is fill that out with some code now. We have a template for loop. This is a Jinja2 for loop. We're looping over all the employees that were in our context from the database, and for each one of them we're rendering a table row. We use the employee.firstname to reference the first name, and the same for the other fields. You'll notice as well that the department, we reference the employee.department.name. So we're using that relation that we specified here on line 12 of the employee model, and that defines a relationship from the employee to the department. And that means that we can then reference the department and follow the foreign key and reference fields on that department itself. So that's the template for loop. Let's save this and go back to the page. If we refresh, we now get this table containing our employees. Now the scenario we're going to use Alpine for here is, imagine that we wanted to filter this table by department. For example, we only want to get all sales department employees. What we could do is we could send another request to the backend and do the filtering there, but that's an extra query over the network. It's an extra query on your server, increasing the load. You might want to offload this work to the client, and that's where Alpine.js or Hyperscript can come in useful. So we're going to define an Alpine component for this task just now. Let's go to employees.html, and to this div at the top, we're going to define an xData directive, and that's what defines an Alpine.js component. That's a JavaScript object, and we're going to set a field on that object called results that will default to an empty array. Now what we now want to do is amend our FastAPI endpoint. We want to serialize the employees to JSON and then pass those as the xData. What this means is if we go back to main.py, we fetch all the employees here on line 16, but instead of just putting them in the template context, what we're going to do is serialize those to JSON and then store them within the X data, i.e. within this Alpine component, and that will allow Alpine to do the filtering on the front end, and you won't need to hit the server by doing this. So let's go to main.py. I'm going to bring in a couple of imports at the top here. So I'm going to put this here from FastAPI.encoders. We're importing the JSONable encoder. Now at this point, the imports are a bit of a mess, so we're going to use a tool called isort to clean that up. If you don't have this, you can install it with the pip install isort command, and then you can run isort on the file. So the file's called main.py. If we run that, it will fix up the imports in our file so that it's more Pythonic. Now let's get back to serializing these employees here. We're going to need to change the query that we're issuing here. So I'm going to comment this line out here, and we're going to define a new query. We'll call this variable statement, and it's going to be equal to a select, and we're going to pass two objects to the select, the employee and the department. And these are the two models that we created. And because we're getting rows for two tables, we need to join them up. So we're going to use a .where, and we're going to specify where the employee.department ID, which remember is the foreign key to the department table. We're going to join based on that department ID being equal to the department table itself's ID, so that will join up the right data in the database. So that's our statement. What we now need to do is gather the results of that statement, and we do that by calling the session.exec function. We pass the statement to that, and then we can call .all in order to get all of the results. Now it turns out we can serialize these results to JSON. I'm going to go to the FastAPI documentation. FastAPI comes with a JSON compatible encoder, and this JSONable encoder function, that's what we're going to use in order to serialize our results from the database from Python objects into JSON code that can be passed to Alpine. So let's go back to VS Code, and we'll define a variable here called employee data, and we're going to set that equal to the result of calling JSONable encoder, and we pass the results we got to that function. We're going to then change what's being passed to the employees in the context, and we're going to use the JSON module from Python, and we're going to call the dumps function and pass the employee data that we got to that function. And make sure if you're using the JSON module here that it's imported at the top. So now we have JSON data in our employees variable in the context. Let's go to the employees template here, and we'll remove the array here, and we can reference the results of that JSON conversion process here in the X data directly. So we'll reference that here. It's called employees in the context. So we're now setting the results in our X data equal to that JSON data of the employees. And now that we've done that, we can change the code in our table body here. Currently we're using a Jinja for loop. Let's remove that for loop, and we'll also remove the end for as well. Now when we want to loop over data with Alpine, we define a template element, and we use the x_for directive. And in this case, we're going to reference each result in our results that are stored here within the X data. And don't forget to close that template element below. Now the structure of what we have has changed. We're now doing a select on two tables. Here it's the department table and the employee table. And what I want to do is print out the first result that we get back here with the index notation here. We're indexing in at element 0, and then we can restart the 𝗬𝗍𝗀 server. And if we go to the employees template, I'm going to remove this code here for now. We'll bring that back in a second. Let's go to the page, and we don't get any results at the moment because we removed the code in the table body. But if we go to the terminal, we can see that the result of calling that print statement, we have an employee object and also a department object with the data that we've requested from the server here on this statement in line 21. Let's actually move that down a line, and we're going to reference the employee data, which is what you get after converting the SQLModel instances to Python dictionary. If we refresh this page and go back to the terminal, you can see the JSON has two top level keys, one for the employee and another for the department. So what we want to do when we reference the employee's first name, we want to reference the employee.firstname. So let's go back to employees.html and bring back this code. Now we're going to render this text using Alpine, so let's remove this from the TD element, and we're going to define an x-text directive, and that's going to equal the result that we're iterating over here in the for loop, and we have to reference the employee object's first name. And we're going to do the same for the other three fields. In the case of the department's name, we need to reference the department object. So let's now save this and go back to our page and refresh, we're now getting the same results as we had before, but we're using Alpine.js here. We're using the data that we have in our X data, and we're looping over that in order to render these table rows. So it's quite a different setup from simply using Jinja2 and rendering a partial, but the benefit of this is we can now filter this table very easily with client-side behavior. So let's now add a simple form to this page and allow users to filter down this table by department. Let's go back to our main.py file here, and within this function I'm going to remove the print statement. What we need to do is get all unique department names from the data in our database. Now we already have a query of results here that we're converting to Python dictionaries with the JSONable encoder, and you can see the structure below here. For each object from the database we have a department that contains the name. So what I'm going to do is paste a line of code here, and this is going to get all unique department names from the database. We reference the department name for all rows in the data, and we use a list comprehension to get all of those and pass that to a set object in Python, which will then return only the unique department names in the database. We're then going to add that to our context, so let's clean that up a little bit here. And the third key in the context is going to be those unique departments that we gathered here on line 24. So we now have the unique departments in the context. Let's go to our employees.html template, and to the X data I'm going to add a new key here called chosen department. We'll set that initially to null, and then above the table I'm going to paste in some code here. It's a select, and this select field has an 𝗬𝗵𝗽𝗶𝗹 directive that's set to the chosen department in our X data. What that means is when we select a given option that we have below here, it's going to set that chosen department state to whatever option that we've selected. And the options are gathered by looping over the departments in our context. And for each department we render the option and the value is equal to that particular department. So for example, sales or accounts. What we can now do, if we scroll down to the for loop, what we can do is actually filter the results that we're actually displaying. We can say results.filter, and for each result here we'll use a JavaScript arrow function, and we can say that results department name must be equal to the chosen department. So just to reiterate what's going on here, we are selecting a department with that select option here. That will set the state in the X data to whatever has been selected, and then in our for loop here, our Alpine.js X4, we're filtering down the results, not to the entire results that we have in our data, but instead we're filtering it down based on the department name. It must be equal to whatever is chosen. Let's save this and go back to our page and refresh. We have this simple select box at the top. We now see that there are no data in the tables, but if we actually select something, for example sales, we get back the rows for employees that belong to that department. And similarly, if we go to management employees, we get back those. Now one problem is when we initially load the page, there's nothing there. We can solve this by adding a catch-all option above here in the select statement. So before the for loop, we can add another option and we'll say the value of that is all. And we can also make that default selection in our X data at the top. And what we're going to do now is amend this X for loop. Now if the selection is set to all, we want to return everything. So what we're going to do when we call filter, we can use the first part of the filter to check whether or not the chosen department is equal to all. Now if it's equal to all, we want every single row to return true. So we can chain an OR statement to that. If the chosen department is all, we'll return true for everything. However, if the chosen department is something else, what we're going to do is go to the second part of this filter, and then we do the check on whether or not the chosen department is equal to the department name for the given object that we are looping over. So that's a simple fix for that. Let's save that file and go back to our page. If we reload, we see that we get all results by default at the beginning, and that's because we've set the chosen department to all when the page first loads. If we filter that down to only sales, we get only the sales employees, and the same for accounts and also for management. If we then go back to all, it's going to evaluate to true for every row, so we get every row back in the table. So that's all I want to cover for this video. This setup can seem a little bit complicated, but the benefit is we can do all this filtering on the client side without interacting with the server, and we do that by converting our database data to JSON and then passing that to our Alpine components using the Jinja2 templates that we set up with FastAPI. If we go to our main.py here, we convert the results from the database to a dictionary using this JSONable encoder, and then we pass that to our employees context after converting the dictionary to JSON data with the JSON.dumps function. That is then passed to our xData directive at the top here, and we can use the Jinja syntax to reference that particular variable in the context. And we then loop over these with the xFor directive from Alpine for each result in our results, and then we also add the filtering step in order to filter down the employees to the correct department. And of course, if you find this too complicated, you could add a very simple FastAPI endpoint that returns your employees as JSON data, rather than doing it in the same function that you're returning the template response. But the benefit of doing it this way is that we have a single network request to serve the template and also to convert the database employees to JSON data for Alpine.js. So that's all for this video. Thank you for watching. If you've enjoyed the video, please like and subscribe to the channel, and we'll see you in the next video.